You were just introduced to calculating molar mass. In this video, we will apply molar mass as a conversion factor in order to convert between grams to moles and vice versa. This first problem states, calculate the number of moles in 66.7 grams of cobalt-3 hydroxide. So the first thing we need to recognize is, what is this conversion asking us to do? What we have is we need to recognize our given value. Our given value is 66.7 grams of cobalt-3 hydroxide. And the question is asking us to calculate the number of moles. So our conversion here is going from grams to moles. What relates grams and moles? Molar mass. So before we can do the direct conversion, we need to recognize the chemical formula of the substance and calculate its molar mass. Okay, so let's begin. So our goal is to convert 66.7 grams of cobalt-3 hydroxide. Let's review what the chemical formula is for cobalt-3 hydroxide. Cobalt-3, the Roman numeral here indicates to you the charge on the transition metal cobalt. So this is cobalt with a +3 charge. Okay, so we have CO with a +3 charge. And then we have hydroxide, which is a polyatomic ion that we learned in the previous chapter. And it is, well, actually in the previous lesson, sorry. It is OH. Hydroxide has a -1 charge. Okay, so if we have a +3 charge for cobalt and a -1 charge for hydroxide, those charges are not balanced, okay? So a +3 charge does not balance a -1 charge. So what do we need to do? What we're gonna do is what I call the crossover method, okay? So when I do the crossover isn't used for anything that's a negative or a +1, but if it's a number that is not 1, then that number gets crossed over to be a subscript. Okay, so what we're going to do here is this is just a trick for writing out the chemical formula and balancing charges. Okay, so I'm going to actually draw this a little bit bigger so it's visually better. So we have cobalt with a +3 charge, hydroxide with a -1 charge, okay? So subscripts that are not written are always assumed to be 1. So if we were to cross over this, you would not write the subscript 1. So that's why I say only cross over the charges that are greater than 1. So we're going to take this 3, cross it over, and it's going to become the subscript for the hydroxide. So what is that going to mean? We need to put the polyatomic ion must go in parentheses. The polyatomic ion must go in parentheses because the OH represents the entity of hydroxide. Okay, so without the parentheses here, we would not be able to represent hydroxide. If we were to write it as COOH3 without the parentheses, what this is representing is going to be 1 cobalt, 1 oxygen, and 3 hydrogens. It does not represent 3 hydroxide ions. So you must recognize the importance of including the parentheses around the polyatomic ion. So treat the polyatomic ion like it's its own element because it defines a particular particle. So it's an ion, okay? So polyatomic ion includes more than one element that's been combined together to form an ion. So hydroxide is OH. When we put it in parentheses with a subscript 3, that means that we're going to have 3 hydroxide ions that balances the 1 cobalt ion that has the +3 charge. Okay, so now that we've reviewed that, that's going to be the chemical formula that we will use to determine the molar mass of our substance, cobalt-3 hydroxide. So we're converting grams to moles of cobalt-3 hydroxide. Okay, so when we're converting grams to moles, what we need is molar mass. So therefore, we must do a calculation first before we can begin the conversion. So let's begin. Using our chemical formula, we see that we have 1 cobalt atom, we have 3 oxygen atoms, the 3 gets distributed, and then 3 hydrogen atoms. Then we're going to total together each of the masses. So cobalt, in order to determine the mass of cobalt, we need to look at the periodic table. I am looking at the periodic table on my desktop right now, and I see that the molar mass of cobalt is 58.93. Okay. Where is my screen? Here. 58.93 grams per mole. Every periodic table has slightly different rounding. So if you looked at a different periodic table than one that I may have looked at, then you may see that this might be 0.94 or slightly different. Okay, so remember that there could be just slight variations between periodic tables. But in either case, you're still going to get around the same molar mass. So as long as you're showing what numbers you're using, I'm going to accept whatever it is that you provide to me as long as it is around the expected value. Okay. Now, 3 oxygens. 3 oxygens would be 3 times 16.00 grams per mole. And then 3 hydrogens will be 3 times 1.01 grams per mole. Okay, so now we're going to add these together to give us the total mass of the elements that make up cobalt-3 hydroxide. So that's going to be what I am seeing in my calculator is 109.96. 109.96 grams per mole. Okay, so now that we have the molar mass, we need to remember that the molar mass can be used as a conversion factor to convert between grams to moles or moles to grams. So depending on how we write it, well, this is written as grams per mole, which means the amount of grams of the compound, cobalt-3 hydroxide, in 1 mole of cobalt-3 hydroxide. Okay, so that can be written like this. We can write this as 109.96 grams of cobalt-3 hydroxide per 1 mole of cobalt-3 hydroxide. Okay, So this is the conversion factor of how we're going to apply molar mass as a conversion factor. And remember, conversion factors can be flipped in whichever way that is needed to cancel units diagonally. So let's look at what we're starting with. We are starting with 66.7 grams of cobalt-3 hydroxide. Now, looking at our conversion factor here, can we use it as is or do we need to flip it? So if we have moles on the bottom here, and our goal is to cancel grams on the bottom, then this fraction, conversion factor, must be flipped in order for us to convert grams to moles. So therefore, I will put 109.96 grams of cobalt-3 hydroxide on the bottom per 1 mole of cobalt-3 hydroxide on top. Cancel the units diagonally, and then you will be able to solve with your calculator. So this is very similar to like you just did in chapter 2 when you were doing conversions using molar mass of elements. Now we are applying it to compounds. So to do this calculation, we're going to divide 66.7 by 109.96. And what I am seeing in my calculator, I'm going to round my answer. Okay, so in my calculator, I see a lot of digits. I see 0.606584212. Okay, that's a lot of digits. We don't need all those digits because we follow significant figure rules. So according to this calculation, the least number of significant figures is what we're starting with here, 3 significant figures. Okay, so therefore I'm going to round my answer to 0.607 moles of cobalt-3 hydroxide. Okay. Remember to include the compound formula in order to indicate what it is that the moles is describing. We are describing the amount of cobalt-3 hydroxide in moles.